Okay, I hope you can see my screen right now. Okay, this is officially I'm going to start with Bossard Engineering 3C webinar series number 1, compliances. And today we do it via Microsoft Teams on today, 29th April, 10:30. And before we start, okay, make sure you can hear me. The sound is good. Okay. If not good, okay, check your ear. Okay, this is a kind of a statue on my desk. Okay, I want to show you guys. Okay, you close your ear, of course you can't hear. Screen. Okay, make sure you can see my screen right now. Okay, don't close your eyes, otherwise of course you can't see. And then we have a recording for information on this session. Okay, so in case you want to review back on these trainings, then we'll be able to show you. And of course, by default you are being mute. Okay, because we don't want to have a background or noise behind. So fasten your seatbelt. Again, I want to take you through a very quick 10 seconds quick intro of this webinar series. Okay, fasten your seatbelt, sit tight, and be ready. We shall start now. And very good morning. It's me again, Wai Boons. You can call me officially Mr. Lai. And a lot of people call me just Boon. Okay, I'm an engineering and quality manager in charge for Bossard Malaysia. Already in this industry more than 10 years. And in between, I have other career working in other organization for operation risk management. So with this quick intro, I'm going to move into our so-called the webinar for today. And because of the situations, everybody know that this cute little virus, COVID-19, have caused us, all of us, work from home today. And in Bossard Malaysia, we have launched a series of webinar, and engineering is part of in this program. And today we're going to talk about the compliances, okay? Save our Mother Earth. And then the following 2 weeks, there will be another 2 subjects. The ultimate aim of this webinar is, okay, how using a fastening elements or fastener or screw, we can have a better future. Fastening for a better future is a theme for our webinar. Okay, so because we talk about COVID-19, okay, so let's look at the current COVID-19 crisis. Just a quick one, a quick sharing before official start. Okay, there's a lot of projections from a lot of experts. Okay, in fact, when we look at Malaysia, we don't look far over Malaysia. We know that the lockdown started in mid of March, and then now we are like long time, okay, a month plus, okay. So in fact, there's an expert from JP Morgan predict Malaysia COVID-19 will be peak in mid of April. In fact, I think it's pretty much true because for the past 10 days, we have 2 digits of infected numbers. So if you look at the phases, okay, just now I shared with my team, okay, actually today marked a very important date because we are moving into phase 4 of lockdown. It's a cleaning phase, okay, there's another experts talking about it. Different phases have different meaning, monitoring, prevention, recovery. But bear in mind, okay, we are almost come to the end, okay? So guys, ladies and gentlemen, there's always a light at the end of tunnel. Phase 5 is coming. Freedom will be belong to us. So stay tuned, okay? Stay healthy. Okay, understanding the what I call the history, okay, is very important in any of aspect, okay? Let's look at the history of compliance development in past 20 years, okay? So let's, okay, revise some history, okay? Sejarah, okay, hari ini dalam sejarah. So this year is 2020, okay? We back to year 2000, okay? Y2K years. And in mid of year 2000, European Unions launched a directive called ELV, End of Life Vehicle. The directive number is 2000/53 EC. The aim of this directive is to address the hazardous huge automotive waste. They estimated back then 7-8 million. I think easily now we are talking about more than 10 million tons yearly. So ELV started. Okay, back then there's no ROS, no REACH. When ROS been launched then? Actually, ROS launched in 2002, mid of 2002. Okay, and actually ROS is built on top of ELV. Okay, ELV only have 4 elements, but ROS have 6 elements. Okay, so actually ROS is not the first. ROS is building out from ELV. Okay, so technically speaking, ROS number 1 is the son of ELV. So of course, when they launch this thing, okay, this create a lot of concern in industry, how they comply. They give a grace period, 3 years, approximately 3 years. And then, of course, along the line, back into 8 years down the road, they have ROS number 2, okay, Directive 2011/65/EC, okay, where they have some assumptions because the industrial expert feedback, oh, we can't comply, or how's the status, then they revise the directive. And some of you, most of us should know that ROS, the latest ROS directive is ROS number 3, launched in 2015. So all this is not new now, okay? It's part of our life, our operations, okay? Some customer request about it, okay? So to make things more complicated, so in between, okay, when ROS 1 and ROS 2, there's another regulation called REACH. Ooh. Okay, the abbreviation of registration, evaluation, authorization, and restriction of chemical, responsible by ECHA, European Chemical Agency. So they're talking about a lot of SVHC, a much more what they call scope compared with ROS. Later we'll talk about this. Okay, so all this, why we need that? Because the waste, we talk about waste only, the export of e-waste in different regions, even countries, a lot. There must have a regulation to regulate all this. So, talking about e-waste, it's all over the world. Okay, from Europe, from US, China, India, and even ourselves locally. But I think last year there's one news that captured everybody's eyes. Wow, Malaysia become a dumping waste for a lot of countries. And early this year, Malaysia just returned 42 containers of illegal plastic waste back to UK. Wow, what happened then? Okay, why? Okay, since when Malaysia become a dumping place? And just very recent also, Malaysia sent back more than 4 tons of plastic trash back to 13 countries, rich country we're talking about in Europe, a majority, saying that we refuse to become a rubbish dump of the world. Okay, so what is the spirit of ROS and REACH? Now, when I prepare this slide, I kind of, wow, I relate these two together. They should actually talk about ROS. They should restrict the waste of export. Why they need to export the waste to other countries, okay, like Malaysia? Instead of talking about REACH, okay, they should say return back all the trash to them, okay? So in case of some of you might not have an understanding idea how much is 4.12 tons of trash. Okay, I give you a scenario. Actually, a car, one sedan car, a normal car, the weight of one car is approximately 1 ton. So we are talking about 4,000 cars dumped to Malaysia. Actually, they should play a bit smart, okay? If they can dump 4,000 cars, I think Malaysian will not make too much noise. That's just a joke aside. Okay, so then go back to the history chartboard that we have presented. I showed to you. Okay, then come across that I think some of you might heard about this. How about we, WEEE? Wow, so many regulations. Well, in terms of waste management hierarchy, if you look at this, okay, ROS and REACH actually is the most, I would say, upstream. Okay, they will try to eliminate and reduce the waste. Whereas WEE is talking about how to reuse, recycle, and dispose, how to dump, okay, how to manage the waste. Okay, so it's not applicable for industrial player like us. We are talking about ROS and REACH, not WEE. Okay, so after a series of regulation from the EU, and with the ELV, ROS 1, 2, 3, WEE, REACH, etc., many countries impose their own regulation as well, because want to show muscle, especially the 2 big countries in the world, US and China. They start to have California Proposition 65, Dodd-Frank Act 15042, and China ROS. Wow, make things a bit more complicated. So I know this is a lockdown period. Okay, one of the most worried, okay, especially for guy, you starting to have long hair, okay. Once upon a time I have the problem as well. So many things, confusion, where to focus, ELV, California, China Ross. And today we're going to focus only two, don't worry, Ross and Rich, and there are differences, okay. So the fundamental of understanding Ross and Rich. Okay. So I hope that so far so good, okay, on this my delivery, my tempos, okay. So let's move on. Okay, Ross and Rich, the scope is different, okay. Ross is applicable for electrical and electronics, medical devices, and selected automotive sectors, but Rich apply to all entities that use, distribute the chemical, regardless the origin, whether it's in or outside EU. So their differences is very, I would say, vast difference, okay. Just now earlier I mentioned Ross only concentrated based on the latest Ross tree, only 10 elements to be compliant. But Rich have more than, to date, earlier this year, 205 substances, SVHC, listed in so-called candidate list, which will be updated quite frequently depending on the market needs, sorry. Okay, but they have similarities, as I said, okay, both seek to reduce the use of hazardous element for human health protection. Okay, so in terms of specimen reference, okay, Ross is talking about by article, individual parts, as long as homogeneous material. I highlighted this homogeneous material, later I'll explain. Whereas Rich, they distinguish between substances, preparation, and article. Okay, concentration limits, okay, I will not view into details, but you can check the what I call directive in Ross and Rich respectively. They are talking about by weight percentage, 0.01 to 0.1. Okay, reporting obligations is something very interesting. Okay, all articles supplied under Ross to the industry that I mentioned earlier, it should be reported. Whereas Rich, you only trigger when the SVHC supply more than 1 tons per year. That is something very arguable or tricky. Okay. And homogeneous material. Okay, what is the definition of homogeneous material? Material that cannot be mechanically disjoined into different material. So like the diagram that you can see, okay, schematic, what I call assembly, you can see the motor, different components assembled together. Can they be disjoined? Of course. You just unscrew, unplug, it can be disjoined. Okay, this is not homogeneous. Article, a bit lawyer term here, okay, bear with me. All objects where its functions determined greater degree by the shape and design by its chemical composition. I know it's very tricky, but I will give example later. Okay, how to define article. This is a simple chart of how to classify article and the different types. Let's take a screw that most of us know. Okay, steel fastener with zinc plating. So the first question we ask, does it have constant property and composition? Obviously no, because there is a steel-based material and zinc plating. So it's a mixture. Can it mechanical disjoint? Mean we can separate the zinc plating and the fastener itself? Unlikely. Okay, no, the question is. So this is a homogeneous material. And when you use screw, when you fasten the screw into your product, will the screw change? The answer is obvious. When you fasten the screw remains a screw. Okay, the screw will not turn into others. Okay, composition. So screw remain a screw after assembly. So this is article. This is what does it mean? Design of the article itself. You will not change, not because of the chemical composition. Okay, I hope it's clear. So there's a lot of hazardous elements in what I call in the Rich and Ross. But one of the most common, some of the most common is chromium. Okay, one of the common material is one of the most abundant element in the earth. In liquid form, watery form, chromium exists in 2 chemical forms: chromium 3, called trivalent, or chromium 6. Okay, 3 plus or 6 plus. It's a little chemical. Okay, bear with me. Okay, but not too deep. Don't worry. But chromium 3 is essential to human body. I'm not doctor, but this is the common understanding. Chromium 3 plus is essential for our body metabolism, to balance the glucose and etc. Okay, but chromium 6 is classified as non-human carcinogen. What is carcinogen? Is the root cause for some cancer in medical term. it can cause lung cancer, asthma, skin ulcer, and etc. So it's very dangerous. That's why compliance, okay, which they try to reduce this chromium 6. Not chromium 3. Chromium 3 is still good to us, body. Okay, so my question to you, okay, to the gentlemen, okay, to the participant today, is chromium 6 still available in fastener industry? If you think it's yes, type 1 in your chat box. Okay, sorry, just now earlier I should say, if you have question, you can type the chat box, insert your question so that we can pick up your question at the end of the session. And you type 2. If you say chromium 6 no more in fastener, quickly, we'll do a quick count. Okay, I will not review the answer. The answer will review later in the sessions, so that I can keep you guys follow these sessions. Okay, key in 1 or 2. Is chromium 6 still available in fastener industry? Okay, so I'll move on to the next chapter. The assessment from complete product. Still a small little fastener. Okay, so let's look at products nowadays. Okay, the advancement of electrical product. One of the most appealing element is product downsizing. Okay, so we can combine everything. Okay, with the handphone they have today is all in one. You can listen to the song, you can call, you can capture camera, you can do a lot of stuff. So this is nowadays the advancement of technology. Okay, make the product easier and very functional. But the fundamental of all these products, regardless it's old product, new product, we still need assembly, right? Okay, different components put together, small little screw used to fasten them together, and so on. So if we look at inside the products, okay, this is a typical PCB board with some element inside or on top of that, assembly on top of that. As you can see, some article or product being screwed, using screw fastened in. Some are just plug in, okay, like the knob just plug in, okay, and part of the product are soldered. So there is a difference from rich and raw perspective. Rich, if you supply lead PB, the weight must be related to the soldering material. It's responsible of supplier to declare how much lead inside, the soldering material. But for rich, lead weight must be related or calculated based on the weight firmly interconnected with the components. Okay, talking about the whole complete product. Okay, so that is the difference. So it's in different perspective of compliant declaration. To supplier, we're talking about single article homogeneous material. To customer, it's a product level. We talk about different component level, whether they are joined or not joined or interconnected together. Okay, so there are a lot of key elements, as I said. Okay, rich already have 200, already have 205 year to date. Raws have 10, even though it's 10. But today we're not going to explain one by one. We just want to give you a key, okay, which is more applicable for fastener industry. So I have listed down lead, cadmium, hexavalent chromium, okay, mercury, and other hazardous elements like PBB, PBDE, and so forth. And we're going to examine two elements, bum lead and hexavalent later. Zoom into the fasteners, okay. Whereas the mercury, PBB, PBDE are more applicable for a lot of our other supply like cable ties, okay, some clinching stuff, okay. So some of the elements are used for certain purpose, for example, to increase the fire retardant of the products. So I'll not touch on this. This is a bit different field from my expertise. So I'm going to zoom into the fasteners. Okay, lead and chromium. Okay, about zinc plating. Okay, if you customer just say I want zinc plating, actually we can give customer zinc plating, but zinc plating itself is very dull. Just like this photo shown in my presentation, of course, it's not look very clear. It's actually dull, gray color. Only when you subject them chromatizing process, then the zinc plating will become different color: white, blue, iridescent, yellow, olive, and black. Okay, so all of them not just different in terms of cosmetic color, different by color, but according to ISO standard 9227, there is a different performance in terms of source spray test. But today, this is not our focus. Okay, this will be covered in our other seminars topics. Just to give you a quick understanding, if you are talking about, you want to compare the corrosion resistance, the first is olive, second is yellow, third is zinc blue or white, and the final one is zinc black. Okay, just to give you some idea. Okay, so let's move on. Chromium 6. So when you have chromatizing process, of course, if chromium 6 is being used, of course, you'll be part of your material. Okay, if you are talking about a small, medium size of fastener, M5 milo, zinc plating is about 3 to 5 micron. We are talking about chromate layer in the range of 0.1 to 1 micron. So for a single article, it could possible, okay, less than 0.1% of the total article weight. Okay, it's very important, okay, because it will determine whether this product comply or not comply. Okay, zinc yellow, you know that use a lot of chromium 6. Okay, we have base material zinc. Okay, on top of that, okay, there's a chromate layer. Is there any substitute, any solutions, any alternative? Of course, there are. Nowadays, industry are moving to use chromium 3, as I mentioned or explained earlier. It's compatible, but the problem of chromium 3, because chromium 6 is so good, to replace this guy is not easy. So chromium 3, they need to have very thick passivation layer or chromatization layer. Okay, and also I put an inverted comma here, look alike. Actually, at the beginning, okay, when the plating house tried to use chromium 3 or what I call the chemical, they can unable, until today, they're unable to get the color of zinc yellow. That's why at the beginning of the implementation of ROS, okay, a lot of suppliers came back to us, yeah, I give you zinc yellow, but the actual product is not yellow. Sounds funny, right? That is a fact, and still happening today. Okay, because we are talking about corrosion resistant performance, okay, not a cosmetic. So it takes us a bit of time to convince customer. Some supply even more creative, they put coloring on top of the so-called chromium 3. Okay, so for us in Bossard engineering, we are having other consideration. If this is changed in the layer thickness, the assembly setting may be changed for critical application. So customer, you may need to take note. And if you move on, okay, chromium 6, if customer insists want to have chromium 6, okay, the manufacturers, because they use chromium, the hexavalent, of course, you're subject for authorization under REACH, but the use of product are not affected. Okay, but you need to understand the threshold, whether it's more than 0.1. In this case, is REACH compliant? It's no. Okay, is it more than 0.1 of the article? If this is yes, then this is not ROS compliant. So this is word of caution. Depending on application and situation, ROS and REACH, they are no longer corresponding to each other. Okay, REACH comply doesn't mean sometimes cross conformity. Take notes. Okay, lead is an added element to certain material to improve machinability because of the lubricating qualities. Free cutting steel, for example, got 0.35 of lead, brass, bronze, and aluminum, etc. So of course, today market, some industry offer lead-free options, but it's very limited. Okay, so of course the price also you can imagine when the supply is limited. Okay, but ROS or REACH aware of this situation. There is an exceptional list given under this directive for lead or PB, depending on the application. Some application they still allow certain lead to be used. So check in the REACH or ROS which application and your product entitled or applicable to. Okay, if customer would like to use the brass fastener for conductivity purpose, okay, what happened if the brass material with 3%? Okay, so in terms of FVHC, yes, it's already exceed the limit. Is it more than 0.1? Yes. So it's the obligation of the supplier to notify customer under REACH. And as for the ROS, lead is exceed the limit nonetheless, but it still can be complied because of the exception list, depending on the application. Okay, so we need to check, okay, whether it's applied to your product or not. So in short, Very short. In short, the consideration of aspect of the compliances, okay, these are the three aspects I can list up, I summarize here. Alternative solution, whether there is any alternative solution for your product. Okay, second, whether the article product, whether it's compliant to ROS or REACH, and finally, you change whether it got implication to the product overall assembly and reliability. So the challenges for the first one is definitely availability. Second, how you determine the right test and assessment to make sure we can comply with ROS and REACH. And final, product evaluation. We're not talking about article itself or even fastener. We are talking about the whole complete products. So this you need to consider in one complete puzzle, not individually or separately. Sorry to remind you again of your long hair. Okay, I know this is a bit complicated. So you start to scratch your head. Okay, why so complicated? Yeah, not really. And relax. Okay, perhaps you can, like this stage, you think, is there any expert consultation available? Okay, so in fact, our webinar today is actually coming from our one of the services we call ATE, Assembly Technology Expert. And this short seminar, okay, about 30 minutes, is part of our expert education services. Okay, and I will not drill into other experts. Okay, if you have time, okay, please go and understand us better. And there's a lot of topics under this expert education. Just now in my presentation of this webinar, I have touched a little bit on technical introductions and also corrosion resistance of fastener. So these two topics already will take up easily 3 to 4 hours. Okay, so it's unlikely I can cover during this webinar. Okay, I hope you understand on this. And so with this, okay, I almost come to the end of my presentations. Okay, so we still have a good 1 minute to 30 minutes. It's a quite quick, short webinar. I hope can give you some idea, some consideration when you want to assess whether your product is REACH or ROS compliance. Okay. With this, I officially end my session. I'm going to because just now we start with exciting introductions. Now I'm going to end with another introductions of my webinar series. Okay, stay tuned, stay charged, stay positive and healthy. Follow us on social media. See you then in our next sessions. Bye.